In this video, we will solve the October-November 2023 Pure Maths 3 paper. That's component code 31. Subscribe and let's get into it. that becomes plus 1 over 2 cos x, and this is equal to 1 over 2 cos x minus 1 over 2 cos x minus root 3 over 2 over 2 sine x minus root 3 over 2 sine x. And if we simplify, these two will cancel out and we end up with half cos x plus half cos x, which is simply cos x, and then this results in negative root 3 sine x. And then now we want to use the idea that tan x is equal to sine x over cos x. So let's divide both sides by cos x. If we do that, the left hand side becomes 1, and then the right hand side becomes negative root 3 tan x. So if we make tan x the subject of the formula, this becomes negative 1 over root 3, and this is our final answer. Part B, hence find the exact roots of the equation sine x plus 1 over 6 pi minus sine x minus 1 over 6 pi is equal to cos x plus 1 over 3 pi minus cos x minus 1 over 3 pi. We have seen that this can be written as tan x is equal to negative 1 over root 3, and so let's make x the subject of the formula. That's arctan of negative 1 over root 3. Punch this into the calculator and make sure that you're in radians. That's negative 1 over root 3, and this gives us negative 1 over 6 pi. Our interval is x is between 0 and 2 pi. So to get a solution within the given interval, we can simply add pi to this value. This is our principal value. That's negative 1 over 6 pi, and we're going to use PV plus pi n, and n is just a random integer, so when n is 1, we end up with 1 over 6 pi plus pi, and if you punch this into your calculator, you should get 5 over 6 pi. 5 over 6 pi lies within the given interval. Now let's try at n is 2. So that's negative 1 over 6 pi plus pi times 2. You punch this into your calculator, 2 pi minus 1 over 6 pi, that gives us 11 over 6. 11 over 6 pi. 11 over 6 pi is approximately 5.76, and we know that 2 pi is 6.28 and so on. So that means that 11 over 6 pi is within the given interval. I'm sure this should be our last solution within the given interval, but you can always try at n is equal to 3. That would be negative 1 over 6 pi plus pi times 3, which is 3 pi minus 1 over 6 pi, which would give us 17 over 6 pi, which is approximately 8.90, and that's outside the given interval. So we only select the solutions within the given interval, so we can conclude that x is equal to, our first solution within the given interval was 5 over 6 pi, and then our final solution 11 over 6 pi, and this would be your final answer. Now let's move on to number 6. The parametric equations of a curve are x is equal to root t plus 3 and y is equal to ln t for t is greater than 0. Part A, obtain a simplified expression for dy dx in terms of t. Okay, so let's start by differentiating our parametric equation. So dx dt is equal to root t is the same as t to the power half. So if we differentiate it, we get half t to the negative half, and then 3 is a constant, so it will give us 0. And then if we differentiate y equals ln t, we get dy dt is equal to 1 over t. So I'm just going to rewrite dx dt with a positive power. So this becomes 1 over t to the power 1 over 2. And now let's construct a chain rule for dy dx. dy dx is equal to dy dt multiplied by dt dx. Okay, so dy dt is equal to, we're saying dy dx is equal to dy dt. dy dt is 1 over t times dt dx. So we have dx dt. So we simply have to flip our fraction to get dt dx. So this becomes 2t to the half over 1. So this becomes dy dx is equal to 2t to the half over t. And using laws of indices, we can say half minus the 1 that's over here. So this results in 2t to the power negative half. And if we write it as a positive power, that's 2 over t to the half. And we can write t to the half as root t. So you can conclude that dy dx is equal to 2 over root t. Okay, let's move on to part B. Hence, find the exact coordinates of the point on the curve at which the gradient of the normal is negative 2. Alright, so our gradient function dy dx is equal to 2 over root t. We know that dy dx represents the gradient of the tangent. And the tangent is perpendicular to the normal, so the gradient of the normal would be the negative reciprocal. So we can say that m is equal to negative root t over 2. So that means that this negative 2, which is the gradient of the normal, is equal to negative root t over 2. We get rid of the denominator, this becomes 4 is equal to root t. If we square both sides, t is equal to 16. And now that we have t is 16, we can find the coordinates of the point. And to do that, we'll use our parametric equations. So where x is equal to root t plus 3 and where y is equal to ln t. So if we substitute t here, this becomes x is equal to root 16 plus 3. So that's x is equal to 4 plus 3, which is 7. And then we've got y is equal to ln 16. So that just remains as ln 16. So we can conclude that the coordinates of the point are therefore 7 and ln 16, and that would be our final answer. Number 7. The variables x and theta satisfy the differential equation x over tan theta dx d theta is equal to x squared plus 3. It is given that x is equal to 1 when theta is equal to 0. Solve the differential equation obtaining an expression for x squared in terms of theta. Okay, so let's start by separating our variables. So we get x over x squared plus 3 dx is equal to, then let's move both the tan theta and d theta to the right hand side, so that becomes tan theta d theta, and we're integrating both sides. So for the left hand side, we are going to use the method of recognition. If you differentiate the denominator x squared plus 3, you end up with 2x. So let's write our numerator as 2x, and that's x squared plus 3. Notice how our original numerator is x. The only difference here now is that we have a 2. So we can get rid of that 2 by multiplying outside of the integral sign by half. So if you were to simplify this, you go back to the original expression over here. So that means that we can now, if we were to integrate, this would become half ln of the denominator x squared plus 3 x squared plus 3. That's the left hand side, and then we'll put the constant of integration. Now let's look at the right hand side. We can rewrite tan theta using the identity that tan theta is identical to sine theta over cos theta. So this becomes the integral of sine theta over cos theta. Now we'll use the same method of integration as we used on the left hand side. If you differentiate cos theta, you get negative sine theta. Notice how that is very similar to our numerator. The only difference is a negative sign. So we simply multiply outside of the integral sign by a negative sign. So it means that our integral becomes negative ln of the denominator, which is cos theta. So negative ln cos theta. And now what we will do is we're going to use the idea that x equals 1 when theta is 0 to evaluate our constant of integration, c. So this becomes half ln x is 1, so that's 1 squared plus 3 plus c is equal to negative ln cos 0, so this becomes half ln of 4 plus c is equal to, this should be a 0 over here, so that should be cos 0, and we know that cos 0 is 1, so that will become negative ln 1, and half ln 4 can be written as ln 4 to the half, which is the same as ln root 4, plus c. Ln 1 is equal to 0, and then ln root 4 is equal to ln 2 plus c. And so that means c is equal to negative ln 2. c is negative ln 2. Now let's go back to our equation. So that's half ln x squared plus 3 minus ln 2 is equal to negative ln cos theta. Now our goal is to make x squared the subject of the formula. So this becomes half ln x squared plus 3. Let's move the negative ln 2 to the right hand side. So that's ln 2 minus ln cos theta. Using laws of indices, let's combine the two logarithms on the right hand side. So that becomes ln 2 over cos theta. And now let's get rid of this half by multiplying both sides by 2. So that's ln x squared plus 3 is equal to ln 2 over cos theta. And we can write the right hand side as, using laws of indices, we can write this as ln 2 squared over cos squared theta. So this is ln x squared plus 3 is equal to ln 4 over cos squared theta. And now let's apply the exponential function to both sides. So this becomes x squared plus 3 is equal to 4 over cos squared theta. Subtract 3 from both sides, you get x squared is equal to 4 over cos squared theta minus 3, and this would be our final answer. Number 8, part A. By sketching a suitable pair of graphs, show that the equation root x is equal to the exponential of x minus 3 has only one root. So let's draw our Cartesian plane. This is our x-axis, and then we've got our y-axis. So the two graphs that we're drawing are y equals root x and y is equal to e to the x minus 3. So the graph of root x looks something like this. This is y is equal to root x, and I'll use a different color to draw the graph of y is equal to the exponential of x minus 3. So this graph has been translated in the y by minus 3 units. So minus 3 is somewhere here. And so this means that its asymptote is now over here, and our graph looks something like this. This is the graph of y is equal to e to the x minus 3, and we can tell that our two graphs have one point of intersection. Now let's move on to part B. Show by calculation that this root lies between 1 and 2. Okay, so what we can do here is we're going to go back to let me change our color back to blue, and we're going to go back to the equation we've been given. Root x is equal to e to the x minus 3. And let's put all the terms on one side and call this function f of x. So f of x is equal to e to the x minus root x minus 3. And now let's evaluate when x is 1. So f of 1 is equal to e to the 1 minus root 1 minus 3. So f of 1 is equal to, let's punch that into the calculator, that's e to the 1 minus root 1 minus 3, and that gives us negative 1.282. And now let's evaluate when x is 2. So this is f of 2. That's e to the 2 minus root 2 minus 3. So f of 2 is equal to, let's punch that into the calculator, e to the 2 minus root 2 minus 3, and that gives us 2.975. 2.975. Notice how there's a change in sign. The first solution has a negative sign, the second solution has a positive sign. Therefore, we can conclude that, since there is a change in sign, a root lies between 1 and 2, and this would be our final answer. Part C. Show that if a sequence of values given by the iterative formula xn plus 1 is equal to lim 3 plus root xn converges, then it converges to the root of the equation in part A. So we basically have to show that the iterative formula simplifies to give the equation in part A. So the equation in part A is root x is equal to e to the x minus 3. So let's just remove the n plus 1 and the n in our iterative formula. So that would be x is equal to ln 3 plus root x. And we're trying to get to that equation. So let's start by applying the exponential function to both sides, so that this is e to the x is equal to 3 plus root x. And now you notice that we simply have to make root x the subject of the formula to get to this equation. So this becomes root x is equal to e to the x minus 3. And therefore we have proved that if a sequence of values given by the iterative formula converges, then it converges to the root of the equation in A. And now part D. Use the iterative formula to calculate the root, correct to 2 decimal places, give the result of each iteration to 4 decimal places. So our iterative formula is xn plus 1 is equal to ln 3 plus root xn. Okay, and we're going to start with x0 is equal to 1. So this means that x1 is equal to ln 3 plus root x0, which is 1. If we punch that into a calculator, that's ln 3 plus root 1, and that gives us 1.3863 correct to 4 decimal places. and then x2 is equal to ln, this is 3 plus root, here I'll use the answer function on my calculator, so simply substitute the 1 with the answer function, and now you press equals and you get 1.4297 correct to 4 decimal places. And then we move to x3. Don't change anything on your calculator, just simply press equals and you get your next solution. So that's 1.4341 correct to 4 decimal places. And if we actually give this to 2 decimal places, you notice that this is 1.43 and that is also 1.43 correct to 2 decimal places. So we can conclude that the root is 1.43, and this would be our final answer. Number 9, the diagram shows the curve y equals x e to the power negative 1 over 4 x squared for x is greater than or equal to 0 and its maximum point M. Part A, find the exact coordinates of M. Okay, so M is the stationary point, so to get the coordinates of a stationary point, we first have to find dy dx. So we're going to use the product rule. So this becomes x times, let's differentiate e to the power negative 1 over 4 x squared. So that becomes negative 2 over 4. And this is x e to the power negative 1 over 4 x to the power 2 plus, let's hold the e to the negative 1 over 4 x squared and now differentiate the x. So that's 1. And so dy dx is equal to, if we simplify this gives us negative 1 over 2 x squared e to the negative 1 over 4 x squared plus e to the negative 1 over 4 x squared. And now let's factor out e to the negative 1 over 4 x squared. So dy dx is equal to e to the negative 1 over 4 x squared, and that's negative 1 over 2 x squared plus 1. And since we're evaluating the coordinates of a stationary point, we substitute dy dx with 0. So this becomes e to the negative 1 over 4 x squared times negative 1 over 2 x squared plus 1 is equal to 0. So this becomes e to the negative 1 over 4 x squared is equal to 0, and negative 1 over 2 x squared plus 1 is equal to 0. So to simplify this equation, we have to apply the natural logarithm to both sides. So that becomes negative 1 over 4 x squared is equal to ln 0, and ln 0 does not exist, so that means x is equal to no solutions. Now let's solve the other equation. So this becomes half x squared is equal to 1, multiply both sides by 2, x squared is equal to 2, take the square root of both sides, x is equal to plus or minus root 2, and we're told that x is greater than or equal to 0, so x must be root 2. And now let's evaluate the y coordinate when x is root 2. So our function is y is equal to x e to the negative 1 over 4 x squared. Substitute x with root 2, so y equals root 2 e to the negative 1 over 4 root 2 squared. So y is equal to root 2 e to the negative. So root 2 squared is 2, so that becomes 2 times minus 1 over 4, which gives us minus half. And therefore the coordinates of M are x is root 2 and y is root 2 e to the negative 1 over 2, and that's our final answer. Part B, using the substitution x is equal to root u or otherwise, find by integration the exact area of the shaded region bounded by the curve, the x-axis, and the line x equals 3. So let's look at our shaded region. We're integrating from 0 to 3. Okay, so we've got our function is the integral from 0 to 3 of x e to the negative 1 over 4 x squared with respect to x, and we have been given the substitution x is equal to root u. So let's start with the limits. Let's substitute our limits. So our substitution is x is root u. So when x is 0, we've got 0 is equal to root u. That means if we square both sides, u must be equal to 0. And then when x is 3, we have 3 is equal to root u. If you square both sides, you have u is equal to 9. So using our new limits, we can write this as 0 to 9 x e to the negative 1 over 4 x squared with respect to x. So now we need to get rid of this dx, and we're going to do that by differentiating our substitution. So x equals root u can be written as u to the power half. So if you differentiate x, you get 1. If you differentiate u to the half, that is half u to the negative half du dx. And now we want to make dx the subject of the formula, so this becomes dx is equal to 1 over 2u to the half. And we can come and substitute here. This becomes the integral from 0 to 9 of x e to the negative 1 over 4 x squared, and we're substituting dx with 1 over 2u to the half. And remember that our substitution is x is equal to root u, so we can substitute this x over here. If we substituted 0 to 9, now instead of writing it as root u, I'm going to write it as u to the half. Since you notice here, I've written it as u to the half, so this becomes u to the half e to the negative 1 over 4 x squared times 1 over 2u to the half. And so u to the half and u to the half will cancel out, and what we have is there should be a du here, du, and I'm going to move this half outside of the integral sign, so it becomes half the integral from 0 to 9 of e to the negative 1 over 4x squared with respect to u. And now let's substitute this x with, our substitution is x is equal to root u, so let's substitute the x with root u. So that becomes half the integral from 0 to 9 e to the negative 1 over 4, and then you've got root u squared with respect to u, so that becomes half the integral from 0 to 9 of e to the negative 1 over 4 root u squared is equal to u, and this is with respect to u. Now we can finally integrate. So if we integrate, this becomes negative 4 e to the negative 1 over 4 u, and our limits are from 0 to 9, so that is half negative 4 e to the negative 1 over 4 times 9 minus, so this becomes plus 4e to the negative 1 over 4 times 0. And if we simplify here, this becomes negative 4e to the negative 9 over 4, and then this becomes plus 4, and expand the brackets, that becomes negative 2e to the negative 9 over 4 plus 2, and this would be our final answer. Number 10, let f of x equal 24x plus 13 over 1 minus 2x times 2 plus x squared. Part A, express f of x in partial fractions. Okay, so that's 24x plus 13 all over 1 minus 2x, 2 plus x squared. So we've got a linear factor, so that's a over 1 minus 2x. Then we have a repeated factor, so that will be 2 plus x squared plus c over 2 plus x. So let's multiply by the denominator to get rid of all the denominators. So this will become 24x plus 13 is equal to a times 2 plus x squared plus b times 1 minus 2x plus c 1 minus 2x and then 2 plus x. So let's start by substituting x with, we'll do x is equal to half, which will allow us to evaluate a, since it will make this bracket equal to 0 and then this bracket equal to 0. So this would become 24 times half plus 13 is equal to a 2 plus half squared. So 24 times half is 12, 12 plus 13 is 25, is equal to 2 plus half, that's 5 over 2, and 5 over 2 squared is equal to 25 over 4, and that's a. So multiply both sides by 4 over 25, so you get a is equal to 4. And now let's evaluate when we'll do at x is equal to negative 2, and this allows us to evaluate b. So this becomes 24 times negative 2 plus 13 is equal to b, that's 1 minus 2 times minus 2, and so that's negative 48 plus 13, which is equal to negative 35, and this is equal to, we've got 1 minus 2 times minus 2, so that's 1 plus 4, which is 5b. Divide both sides by 5, so you get b is equal to negative 7. And now to evaluate c, we're going to substitute x with 0, and then we'll substitute both a and b with their respective values. So this becomes 24 times 0 plus 13 is equal to a, which is 4, times 2 plus 0 squared plus b, which is negative 7, negative 7 times 1 minus 2 times 0, and then plus c times 1 minus 2 times 0, and then 2 plus 0. So that simplifies to give 13 is equal to 4 times 2 squared, which is 4 times 4, so that's 16. And then we have minus 7 times 1, which is minus 7. And then we've got 1 times 2 times c, which is plus 2c. So 13 is equal to 16 minus 7, which is 9 plus 2c. And so you get 2c is equal to 13 minus 9, which is 4. So that means c is equal to 2. And now it means f of x can therefore be written as a, which we said is 4 over 1 minus 2x. Let's just verify that that's correct. Yes, a is 4 and it's over 1 minus 2x. Then b is negative 7 over 2 plus x, and that's squared, and then we've got plus 2 over 2 plus x, and this would be our final answer. Part B, hence obtain the expansion of f of x in ascending powers of x up to and including the term in x squared. Okay, so f of x, let's copy down f of x. F of x is equal to 4 over 1 minus 2x minus 7 over 2 plus x squared plus 2 over 2 plus x. Okay, so let's start with the first term. We're going to bring the 1 minus 2x to the top, so it becomes 1 minus 2x to the power negative 1. And if we expand this, this becomes 1 plus negative 1 times negative 2x plus negative 1, negative 1, negative 1 over 2 factorial times negative 2x squared, then our big bracket. So this is 4 times 1. Negative 1 times negative 2x gives us positive 2x plus, then let's use our calculator to evaluate the third term. Negative 1 times negative 1, negative 1 over 2 factorial times negative 2 squared, and this gives us 4x squared. And if we expand, that's 4 plus 8x plus 16x squared. Now let's move on to the second term. So that's negative 7. And if we bring the bracket to the top, that becomes 2 plus x to the negative 2. Notice that we have a 2 over here. For us to be able to expand, that needs to be a 1. So let's factor out the 2. So that becomes 2, open brackets, 1 plus x over 2. And this is all to the power negative 2. If we distribute the power negative 2, this becomes 2 to the negative 2. And then we have a bracket, 1 plus x over 2 to the negative 2. And if we expand, 2 to the power negative 2 is 1 over 4. So this becomes negative 7 over 4. And then our bracket, 1 plus x over 2 to the negative 2. And now we can use the formula for binomial expansion. So that becomes 1 plus negative 2 times x over 2 plus negative 2, negative 2, negative 1. And this is all over 2 factorial times x over 2, and that's squared. And so that's negative 7 over 4. That's a 1 over there. And then negative 2 times x over 2 gives us negative x. And then let's evaluate the third term using our calculator. That's negative 2, negative 2, negative 1 over 2 factorial times 1 over 2 squared. So that gives us 3 over 4 x squared. And now let's move on to before we move on, let's expand this bracket. That gives us negative 7 over 4 plus 7 over 4 x, and then negative 7 over 4 times 3 over 4 gives us negative 21 over 16, and that's x squared. Now let's move on to the third term, which is 2 over 2 plus x. And so that can be written as 2 times 2 plus x to the negative 1. Again, we need to factor out a 2 here, so that's 2, and that's 1 plus x over 2 to the negative 1. Distribute the power negative 1, so that's 2 to the negative 1, and then 1 plus x over 2 to the negative 1. And 2 to the negative 1 is 1 over 2, so that will cancel out, and we end up with 1 plus x over 2 to the negative 1. And if we expand this, that's 1 plus negative 1 times x over 2 plus negative 1, negative 1, negative 1, and this is over 2 factorial times x over 2 squared. If we simplify that, that's 1 minus x over 2. And then the third term would be negative 1, negative 1, negative 1 over 2 factorial times 1 over 2 squared. And that gives us 1 over 4. So this is plus 1 over 4x squared. Now let's combine our results for all three scenarios. So we have our first set of results from here, our second set is here, and then our third set at the very bottom. So let's write it over here since we've run out of space. So we've got f of x is equal to, let's start with the terms independent of x, so that's 4 minus 7 over 4 plus 1, and then we have the terms in x, that would be 8x plus 7 over 4x minus x over 2, then the terms in x squared, that's 16x squared minus 21 over 16x squared plus a quarter x squared. And now let's simplify. So for the terms independent of x, that's 4 minus 7 over 4 plus 1. That gives us 13 over 4. And then for the terms in x, that's 8 plus 7 over 4 minus 1 over 2. That gives us 37 over 4 x. And then the terms in x squared, that's 16 minus 21 over 16 plus 1 over 4. And that gives us 239 over 16. And that's x squared. And this would be our final answer. Part C. State the set of values of x for which the expansion in B is valid. Okay, so if we go back to part B, you notice that when we expanded for the first one, our x was negative 2x, so we're negative 2x. In the other two scenarios, we were substituting x with x over 2. So it was x over 2 that we were using. And now if we consider both values, negative 2x and we had x over 2, when we are using this formula for binomial expansion, we're saying that mod x should be less than 1. Or in other words, x should be between negative 1 and 1. Negative 1 and 1. So in this case, we use negative 2x and x over 2 as our x values. So when x was negative 2x, we can say that negative 2x should have been between 1 and negative 1. And if you divide through by negative 2, you end up with negative 1/2. And then that's x is less than half. And then if we do the same for x over 2, that would be x over 2. And then that's between negative 1 and 1. Multiplied through by 2 to make x the subject of the inequality. So that would end up with negative 2, x is less than positive 2. Okay, so now that means we have two solutions. This is when x is being substituted with x over 2, and then when x is being substituted with negative 2x. Now, if we are to draw this on a number line, let's say negative 2, negative 1, and say negative 0.5, that's negative half, will be somewhere there, and then 0, 0.5, 1, 2. And we're saying the first, I'll draw it in red, that's for when x is x over 2. We're saying the region that's being satisfied is from negative 2 to 2. And then in gray, I'll draw the other region. That's this region. That's from negative half to half. You notice that this region that I've drawn in gray satisfies both inequalities. So that is the region that we will choose as our final answer. So we can therefore say that our answer is x is between negative half and half, which we can write as the modulus of x is less than half. And that's our final answer. Number 11. In the diagram, OA, BC, D, E, F, G is a cuboid in which OA is 3 units, OC is 2 units, OD is 2 units. Unit vectors I, J, and K are parallel to OA, OD, and OC respectively. M is the midpoint of EF. Find the position vector of M. So what we can do, we want OM. We can say that OM is from OA to AE and then EM. So we know that OA, we've been told, is 3 units, and this is parallel to the unit vector I, so that's 3I. And then AE is parallel to OD, and OD is 2 units and is parallel to J, so that's plus 2J. And then E to M, that is parallel to O to C, and E to M is half of OC. So we can write this as, we're told that OC is 2 units, so half of that would be 1. And since it's parallel to the unit vector K, that's 1K, or we can just simply write that as K. And this would be our final answer. The position vector of P is I plus J plus 2K. Calculate angle PAM. So angle PAM, we can write it as cos PAM. This is the angle between our vectors AP and AM. So we can say the dot product of AP and AM divided by the modulus of AP times the modulus of AM. So it means we first have to find the vectors AP and AM. So let's start with AP. So AP is equal to OP minus OA. So we know that AP is equal to OP is I plus J plus 2K, and then OA is equal to 3I. So if we simplify this, we get that AP is equal to minus 2I plus J plus 2K. And now let's find the displacement vector of AM. So AM is equal to OM minus OA, and OM, we evaluated that in part A, so that's 3I plus 2J plus K minus OA, which is 3I, so AM is equal to 2J plus K. Now let's find the dot product of these two vectors. So our dot product would be, let's write them as column vectors. So AP would be -2, 1, 2, and this is dot AM, which is 0, 2, 1. And so that's -2 times 0, which gives us 0. And then we have 1 times 2, which gives us 2, plus 2 times 1, which gives us 2. And this simplifies to give 4. Now let's find the moduli of both vectors. So let's start with AP. Modulus of AP is equal to the square root of AP, that's -2 squared plus 1 squared plus 2 squared. And this simplifies to give us, let's punch that into the calculator, that's root 2 squared plus 1 squared plus 2 squared, and that gives us 3. And then the modulus of AM is equal to the square root of 2 squared plus 1 squared, so that's 4 plus 1, which is 5, so that's root 5. A modulus of AM is equal to root 5. Now we can substitute into the formula for the angle. We've run out of space here, so that's cos PAM is equal to the dot product of AP and AM, which is 4, that's over here, and then the product of their moduli. So the modulus of AP is 3, and the modulus of AM is root 5. So PAM is equal to arc cos of 4 over 3 root 5. So PAM is therefore equal to This is arc cos of 4 over 3 root 5, and this gives us 0.932 radians. You can also give your answer in degrees since they haven't specified the measurement for the angle. Part C, find the exact length of the perpendicular from P to the line passing through O and M. Okay, so let's sketch a diagram of our problem. So I'll call the line passing through O and M, I'll call it L. And then we've got a perpendicular. Find the exact length of the perpendicular from P. So this point would be P. And it's perpendicular to the line L. So L is line through O and M. So we'll call this point of intersection, we'll call it point X. Now we need to find the equation of line L. And what we can do is we can simply say that R is equal to, we need a point that's on the line, so we can use OM, position vector OM, that's from part A, 3i plus 2j plus k. I'll write it as a column vector, so that's 3, 2, 1, plus lambda, and since this is the line through O and M, our direction vector will also be 3, 2, 1. And now we can find the general coordinates of point X using the equation of the line through O and M. And so that means that OX has the coordinates 3 plus 3 lambda, 2 plus 2 lambda, and then 1 plus lambda. And now let's find the direction vector of PX. So PX is equal to OX minus OP. So PX is equal to 3 plus 3 lambda, 2 plus 2 lambda, 1 plus lambda, minus OP. OP were given in part B, and that's 1, 1, 2. So that's 1, 1, 2, and this simplifies to give, we've got 3 minus 1, so that's 2 plus 3 lambda, 2 minus 1, that's 1 plus 2, 2 lambda, 1 minus 2, so minus 1 plus lambda, and so that's our PX. And if we go back to our diagram, we'll notice that the line L and the direction vector PX going this way are perpendicular. And we know that if two vectors are perpendicular to each other, then their dot product or their scalar product is equal to 0. So in this case, we have Px, which is 2 plus 3 lambda, 1 plus 2 lambda, negative 1 plus lambda, dot, and then we need the direction vector of L, which is 3, 2, 1. And we know that this scalar product is equal to 0. So let's evaluate it. That's 2 times 3, which gives us 6, plus 3 lambda times 3, which is 9 lambda. Then 1 times 2, which is 2, 2 lambda times 2, which is 4 lambda. Negative 1 times 1 gives us negative 1. Lambda times 1, that's plus lambda, and this is equal to 0. Then we have 6 plus 2, that's 8, minus 1, that's 7. And then we have 9 plus 4, 13, plus 1, that's 14. So this is plus 14 lambda is equal to 0. So 14 lambda is equal to negative 7. And then lambda is equal to negative 1 over 2. And now let's go back to the question. What does the question want? It wants the length of the perpendicular from P to the line passing through O and M. So our perpendicular is PX, which means we need to substitute our value for lambda into PX. So we evaluated PX to be this using the general coordinates of the line. And now that we have lambda, we can say that px is equal to, so that's 2 plus 3 lambda, that's negative half here, 1 plus 2 lambda, which is negative half, and then negative 1, negative half. And if we simplify this, that's 2 plus 3 times negative half, that gives us 1 over 2. So we've got 1 over 2, and then 1 plus 2 times negative half, which is a 0. And then we have negative 1, negative half, which is negative 3 over 2. And now what we want is the length of this direction vector. So we can say that the modulus of px is equal to the square root of 1 over 2 squared plus 0 squared plus negative 3 over 2 squared. And so px, the modulus of px is equal to, that's the square root of 1 over 2 squared, that's the square root of 1 over 2 squared plus negative 3 over 2 squared, and that gives us root 10 over 2, and this is our final answer. And I believe that's the final question in this paper. So that's all for this paper. Thank you for watching. If you enjoyed the video, please like and subscribe for more videos like this, and comment down below which paper would you like to see me break down next. Bye bye.